Hello, Math 142. Partial sum of a geometric sequence is given by S sub n equals a times the ratio of 1 minus r to the n over 1 minus r, with the stipulation that r cannot be 0 and r cannot be 1. Let's do a couple of examples. Suppose we want to find the partial sum. Find the partial sum for, say, 1 plus 3 plus 9 plus 27 plus dot 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 plus 6,561. So what would be the number if I added all these terms together all the way to 6,561? Well, the formula given to us is S sub n equals a, okay, 1 minus r to the power of n over 1 minus r. So let's just identify some numbers. What's a? A equals 1 right here. I don't have to do any work for that. What is common ratio? Common ratio is 3, because every term has been multiplied by 3 to get to the next term. Okay. What else do I know? I know that 3 to the power of 8 equals 6,561. Notice that right here I have 3 to the power of 0, then 3 to the power of 1, then 3 to the power of 2, and on and on. So my n must equal to 9. So this is my first term, 3 to the power of 0, 3 to the power of 1 is my second term, 3 to the power of 2 is my third term, 3 to the power of 3 is my fourth term. So 3 to the power of 8 must be my ninth term. And I'm now ready to plug in numbers. So S sub 9 equals 1 times 1 minus common ratio of 3 to the power of 9 over 1 minus 3, put that in your calculator, and you get 9,841. So if you add all those together, you get 9,841. Let's do another one. Go to the next page. Suppose we want to find the partial sum for, find the partial sum for 1 minus 1/2 plus 1/4 minus 1/8 plus dot 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 all the way to minus 1 over 512. Okay. So again, we want to use the formula that S sub n equals a 1 minus r to the n over 1 minus r. What is my a? A equals 1. What is common ratio? Common ratio is negative 1/2. All I have to do is just divide one of these by the previous one, and I get negative 1/2. Okay. What else do I know? We know that 2 to the power of 9, 2 to the power of 9 equals 512. So n must equal 10. Notice that, let me just show you this, that the 1 is same as 1 over 1, isn't it? So this 1 right here is 2 to the power of 0, 2 to the power of 1, then 4 is 2 to the power of 2, then 2 to the power of 3, and on and on. So the first term is 2 to the power of 0. The second term is 2 to the power of 1. Okay, so when you get 2 to the power of 9, you are on the, excuse me, you are on the 10th term. So n equals 10. So let's go ahead and plug that in. And we have S sub 10 equals 1 times 1 minus negative 1 half to the power of 10 all over 1 minus negative 1 half. Let me give myself a little bit of room here. I may need it. And that equals 1 minus 1 over 1024 over 1 plus 1 half. Okay, using LCD, I'm going to combine those 1 and 1 over 1024, and I get 1023 over 1024 over 3 half. And I'm going to go ahead and multiply top and bottom of this complex fraction by 2 over 3, 2 over 3. And that gives me 341, and 2 goes to 10, 5, 1, 2. Okay, so the partial sum is 341 over 512. And let's do one last example. Suppose this time our geometric sequences given to us in terms of using the sigma notation. Suppose you are asked to find the partial sum, find the partial sum for from k to equals 1 all the way to 5, 8 times negative 3 half k minus 1. Okay. And once again, I want to use my formula of S sub n equals a times 1 minus r to the power of n over 1 minus r. So what is a? What is a, my first term? So notice that we are starting with k equals 1. If I plug in 1 in for k, I get 1 minus 1, 0. Negative 3 half to the power of 0 is 1. 1 times 8 is 8. So a equals 8. Well, the common ratio is negative 3 half. I don't have to do any work for that. Common ratio is negative 3 half. And n equals to 5. I don't have to do any work for that either. So let's go ahead and plug this number in. So S sub 5 equals the first term, in this case 8. Then I have 1 minus negative 3 half to the power of 5 over 1 minus negative 3 half. Simplify that and you will get 55 over 2. I think we have time for one last one. Let's do another sigma notation. So find the partial sum for, let's say if we have k equals 1 to 6, 64, 3 half, and then I have on the top, of course, k minus 1. And I want to use my formula that S sub n equals a 1 minus r to the n over 1 minus r. So here, let's see, when starting from k equals 1, if I plug in 1 in here, I get 1 minus 1 is 0, 3 half to the power of 0 is 1, times 64 is 64. So my first term, a equals 64. The common ratio is given to me as 3 half right here. I don't have to do any work for that. And my n is given to me in here. I don't have to do any work for that either. So S sub 6 equals 64, 1 minus common ratio of 3 half to the power of 6 all over 1 minus um, 3 over 2. Okay, and simplify that, and you will get 1,330. Thank you, and I'll talk to you soon.